Hey there everybody, and welcome back to another upbge tutorial where I teach you how to use the Blender game engine. This is part 2 in the series where I'm going to teach you how to do better movement, because last time in part 1, make sure you watch that, we did a very basic WASD movement system, which is okay, but you can't orient your object, so it's not very sophisticated. So this time we're going to build on it. So just as a reminder, what we did last time is we made a very simple, let me make that full screen, a very simple node network that takes our inputs on the keyboard, W, S, A, and D. It goes through some math, and then it eventually moves the object. The result of this, when we use P to run our game, P for preview, is when I use W and S, it goes up and down, and A and D, left and right. So we have a basic movement system. But this is very boring because the cube is always going to be oriented the same way. If I'm going this way, I want it to kind of turn and like face that way. Okay? So in other words, I want to add rotation to this. And there's a lot of ways to do this, but what I'm thinking is instead of just like doing the movement and then the cube rotates based on that movement, let's have W and S. Yeah, W and S up and down, literally go up and down. But A and D, instead of going left and right, let's have D rotate one way and A rotate another way. Okay, so this way we can still go everywhere, but it's a bit more natural. This isn't actually that big of a fix. So we're looking at A and D. I'm still going to subtract them because one is going to go one way and the other one's going to go the other way. So we get a negative with subtraction. All I'm going to do is I'm going to, first of all, remove this Y vector. What this is going to do now is if I hit P, W and S go up and down, but A and D do nothing because they're not connected to anything. Okay? Instead of a move object this time, we're going to go to Objects, Transformation, and this time I guess we want it to rotate. So you don't really want to rotate to because we want to add and subtract rotation instead of set a fixed amount. So I'm going to apply a rotation. We're going to do something very similar to the move object. We want it to use its local coordinate system so that it doesn't really care about the global one. It's just saying, how am I rotated relative to my own origin? What object are we rotating? Well, you can either pick the cube or you can just say use yourself, which is good if you have only one object in the network, but if this network has a bunch of objects, you might not want this. And then for the rotation vector, well, just to see what this looks like, let me increase this by 45 on the Z, and when I run the game, well, I guess it's not doing anything because it's not applying the rotation. We haven't made a condition. What we can say is we can say on update, which is what we did last time. So every time we update the frame or update the calculation, under that condition, apply rotation. So let's see what that looks like. Well, now you can see it's spinning very fast, but we can also go W and S, and it's kind of weird and glitchy. Okay? What's happening here is on every update, we are rotating by 45 degrees, which means it's going to rotate very fast. And because we're oriented different ways, W and S, which go forward and backwards, will go all kinds of directions depending on where we're oriented. So to get this to work for us, all I want to do is I want to put this as a Z rotation. So I'm going to go to Vectors, Vector XYZ, which again is the node we use as a combine XYZ. That's the name here. And I'm going to take this and connect it to the Z component. Now this again isn't going to necessarily be correct, but it's a bit closer. So the way I want you to think about this is when A is pressed, we're going one way. When D is pressed, we're going the other way because we're subtracting. It's a negative. We're putting this only in the Z component, and that's where the rotation is going to be applied for every frame on update. So now W and S go up and down, and A and D rotate it. Not perfect because it's rotating too fast, but you can see kind of the spirit of it. So obviously, a bit of a fix we can do is you can look here. If we look at what we did over here where we did the movement, we had our vectors, yada yada, but eventually we calculated the speed and made it go like 10 times slower. So I think we can do something very similar here, okay? You could either do this before or after the vector. I think it's more natural to do this before. So I'm just going to connect this here. I'm going to say multiply by 10%, by 0.1, and then connect that. This is going to be the same thing, but now it's going to rotate 10 times slower, okay? So now you can almost see that it's usable. And you can do these kind of cool S waves and stuff like that. That would be very hard to do using just the W, S, A, and D system. Now you can play around with what feels right. I still feel like this is a bit too fast, so I'm going to use 0.07 so 7% instead of 10%. And to me, this feels a lot more natural. So now we have basically the same flexibility, right? We can go anywhere we want, but it kind of looks better and it kind of has more going on. And even if we were to kind of like add some geometry to this, it's going to respect it. So this is just a bit of a modification. Let's say this is our character that has orientation. This way's up. You can now see he's like going in the direction of his nose. He's kind of like an anteater character. So that's one advantage of using this method. And I think that's really all I want to talk about for this one. Just so you know, I think it did this when I exited and then like opened up upbge again. I think it did its own normalize and calc speed. But you can do this either by scaling the vector or scaling the input that goes into the vector. And I'll just show you where we're going to go with this. At some point, we're basically going to add a ground plane. So I'm just going to move this upwards. This is going to go on top of the ground, and then we're going to add all kinds of like obstacles and stuff that this has to navigate around. So just as a basic demo, we can run this. And now we're playing in our little environment, and we can go around the wall and go behind it, and then come back around. So that is where we're going to end up going with this, just so you know. But in the next tutorial, get excited because we are going to do jumping. We can move, but we can't go up and down. We can't jump. And to do that, we're actually going to use physics because jumping has to do with gravity and all that. So I'll see you in the next part where we are going to talk about jump physics.